Hello and welcome to SwampUp. We're going to talk today about getting control over your microservice sprawl, one of my very favorite topics. I am Tracy Reagan. I am somewhat of a microservice evangelist. I'm super passionate about configuration management and continuous deployment. I'm also the CEO of DeployHub and its co-founder. I was recently recognized as a tech beacon in DevOps, which is pretty cool. I'm on the board of the Continuous Delivery Foundation and actually served on the board of the Eclipse Foundation for a good time. I'm also DevOps Institute Ambassador and the Community Director for the Artilius Open Source Project, which we're going to talk about a little bit today. My hobbies, big horses, dogs, and I like martial arts. So we're starting to really see an emergence of microservices, and they do require some new DevOps solutions. This is a massive shift in how we write and deliver software. A couple of trends we're beginning to see is the emergence of a service catalog around microservices. It's a huge market potentially for that, 500 million right now, which is pretty big for kind of an emerging technology. And we're also seeing sort of a convergence of continuous delivery and GitOps and what we'd like to call experimentation vendors. This information is in Tyler Jewell's article around trends and foretelling new approaches to DevOps. We also see an increase in the use of DevOps. The CNCF did a study last year, and that study indicated, based on their users, 92% of them say that they're using containers in production now, and that's up from about 84% last year. So we're seeing a continued increase in the use of containers. If those containers are moving to microservice, we're still not clear yet, but we do know that Kubernetes is being used in production, about 83%, up from about 78% in 2019. So the emergence of the containers in production and Kubernetes in production is going to indicate that microservice is going to be the next big shift. I like to use this article that was written by SD Times back in 2019 called "Microservices More Isn't Always Better." And Alexandria Noonan was interviewed, and she talked about her sprawl of microservices. And she'd say, what happened is we would release an update to a library, and then one service would use the new service. And now all of a sudden, all these other services were using an older version. We had to try to keep track which service was using what version of the library. And Randy Hefner says that microservice development falls apart without a coherent, disciplined, managed approach. So microservices are complex, and that's because we're taking our static application and we're breaking it into smaller puzzle pieces. So let's kind of look through what the problem really is. And in order to really understand the problem of microservices sprawl, is we have to understand how we got here. And so we have to look at our monolithic practices compared to a microservice implementation or a microservice architecture. So in our monolithic applications, they're configured and statically linked. That's basically where we start this journey. Most of you have somebody who's like a build manager, and that build manager creates build scripts, these static configuration scripts that figure out how to compile and link and what to use in your compile and link process. Super, super critical position. When they do that, they look at version control and they decide what should be used. They look at, they worry about, pull request and merging and pulling out a main line and recompiling that main line. And that's in essence what CI does, is it looks at these build scripts and says, I've got something new in Git, I'm going to pull it out and I'm going to automatically run my build scripts. At that point, you might call something like Artifactory to do some scanning and look for transitive dependencies, for example. But at the end of the day, what this whole build step did, it was created an application binary and assigned it a version. It may have used the build number as the version, which is a completely logical thing to do. if you were good at what you did, you generated a bill of material report. It showed what libraries were included, what you used. And if you were really good, you produced a difference report. You compared your two BOM reports and said, this is the difference between the previous build and the build we just did. All of this is our North Star in our monolithic approach. And it's the beginning of the CI pipeline. And once this is done, you have a release candidate that may or may not be pushed across the CD pipeline, but you're doing this on a regular, high-frequency basis to make sure that any changes that's being added to Git and is ready to be compiled hasn't broken the build. So how do we know we didn't break the build on a monolith in a microservices world? That's really the trick. So let's think about how a microservice developer interacts in this world. Microservices are built and deployed independently. That's the point. You're going to decompose your application, and you're going to deploy these objects independently. And this is what creates the complexity. Breaking up is hard to do, and no more so in a microservice, going from monolith to microservices. Once a microservice developer has completed his code, he's built his 300 or 400 line Python code or updated it, he's going to create a new container, and he's going to register that container to a container registry. Once that is in the container registry, it's sort of ready to go. It's pushed into dev, or it's pushed into test, or it's pushed into production environments. And this is where the CD pipeline then picks up to take that container and push it to a testing environment or a production environment. Now, if you are still doing monolithic and you're building your container includes your entire monolithic application, you're not really doing a microservice environment, you're really running in a monolithic, and the containers are treated in the same way as the CD pipeline. In a microservices world, that's different, because the microservices are moving independent of your application. And this is the beginning of our problem. And it's driven because the monolithic step, that's the link step, that statically links all of our external libraries that we're going to use, is replaced with APIs, and that's done at runtime. So think about it this way. We are taking our monolithic application and we're breaking it up into smaller reusable components that can be shared. That's the whole point. And we're linking them dynamically at runtime. So we have some challenges to get over because of that. So what's the impact? Well, first of all, we don't have an application version anymore. It's logical at best. We don't have an applications BOM report. It's hard to know what version of a particular microservice your application may be consuming. And it's certainly difficult to generate a difference report to show the last time we built this is what it looked like. Now today we recompiled it, and this is the new BOM report, and this is the differences. This lack of visibility actually creates some bottlenecks for high frequency updates. I'm hearing so often that SREs often feel like they're flying blind when they're releasing a microservice because they just don't know exactly what the impact's going to be. So there's some hesitancy. And while we can push things out on a high-frequency basis, what we end up doing is waiting for it to be deployed to an environment and wait for an incident report, and then use observability tools to try to track the transactions and sort out what happened. Microservice sprawl is another impact of taking our monolithic kind of approach and moving it into a cloud-native environment. And the reason why we're doing the sprawl is to solve some of the problems that I just described. But in essence, we don't have any understanding of impact. We don't know what our blast radius is of a microservice. We don't know if one microservice impacts one application or 20 applications if you're in an enterprise. And that is a problem. So let's just think let's take the heart of the matter here. What is it that we're trying to do, and why is it difficult? First of all, SOAs are intended to leverage shared services, not copied services, which means our monolithic habits have to go away, because monolithic habits actually discourage sharing. We tried to do object-oriented programming some time back, and what we ended up doing is creating we have this concept of a dynamic link library, a DLL, that was supposed to be able to be shared across multiple applications. But we didn't want to do that. Instead, what we did was we brought that library into our environment and renamed it. And in fact, if you think about how Microsoft, Visual Studio works, it will rename it for you. So that was the way we solved the problem. We wanted to use our own version, and we didn't trust to have a shared version. So shared services do present a new challenge. Because the concept is, if you're sharing the service, if you update a particular service, everybody gets the fix at the same time instead of recompiling everything in order to get it out the door. That is the beauty of an SOA, and it's the beauty of microservices. If you have a security problem, you fix it in one place, and instantly everybody who's consuming it gets that fixed. There's no recompile needed. That is the ultimate in business agility. But with this new world, there are no insights into the application and service relationships unless you wait until you get out to the cluster and look at that based on transactions. And that's not even going to really show you a BOM report, what your application consumes, and certainly doesn't give you impact analysis. If one of those services are going to be updated, you might want to know that impact before it goes out the door. So it is our monolithic habits that create the sprawl. And there are human elements to this as much as there are actual tool elements. And in our monolithic world, we really relied on ownership. We want our own versions of the libraries. You hear things like, I don't want unexpected updates. Our team decides when to deploy a new service, even if we don't own it. Ownership. That is a monolithic habit. Lack of collaboration. Our team wasn't told a new service was available. Nobody told us. And collaboration is critical in an SOA environment because you need to have a way to communicate when new features and new services are going out the door. Consistency. We used to hear it worked on my machine. Now we hear it worked on my cluster. So we don't need the new version since it worked on our cluster. We're going to keep that version and move that version forward. And validation. We've never tested our application with that particular version of a service. And this goes back to our trust issue. We have to be able to trust that somebody who wrote a microservices is going to make sure that it's going to agree to those contracts that we have in testing. So let's see what it looks like in action. Not everybody is moving in a Kubernetes or a cloud native environment like what I'm showing here today, but I'm seeing it more than I thought I would. This is basically a monolithic approach to building out your applications running in a clustered environment. So in this case, we have a fictional store called the Online Store Company. There's the candy store, there's the clothing store, and the toy store that we manage in our Online Store Company. We have shared services. We have the cart service, and we have the shipping service, and we have the payment service. Now, because all three teams are not comfortable with trusting when a shared service has been updated, they've asked for their own clusters, for their applications to run in their own private clusters. So for production, we have 3 clusters with 12 pods with 12 siloed services, and the shipping service is drifted. Now, in our case here, the candy store and the toy store are using the same shipping service, but the clothing store opted out or did not know to update the shipping service. So this is sprawl and drift. So instead of everybody reusing things and picking up the most recent version, we have siloed them. This is a monolithic approach in a cloud native environment. It creates a lot more work. Now we have 12 of these pods, and if you multiply that by your dev, test, and prod, you're managing 36. And your applications really are only using 3 shared services. So the sprawl happens really quickly. So it's a balancing act, right? How do we balance the risk and control? Control is given to us when we silo these clusters, because it gives us a high level of control of what we're going to use as a service. But the risk is that if one of those services are updated, you create drift, which means critical fixes may not be consumed by all applications, when they can be easily in a service-oriented architecture and using microservices. So we have to figure out how to manage the balancing act. And part of that managing the balancing act is changing some of our internal culture, because culture matters, and as well as introducing some new tools to foster building out an SOA architecture with some insights. So first of all, trusting the use of external team services is critical. We have to get to a point where application teams can trust using a microservice that they have no control over. And they have to have a culture of sharing components and collaborating around those components. You know, we've worked in improving our collaboration, and you know, companies like GitHub has talked about collaboration for quite a long time. But in an SOA environment, we do have to know if the person on the third floor wrote a really amazing security routine, how do we tell the person on the 8th floor that their application should be consuming it? And we have to think about domain-driven design. I throw this out because if you're really learning and trying to understand how to build out an SOA, DDD is something you should be looking at. We learned about this in object-oriented programming. We didn't implement it very well. We have to at this point. We have to start understanding our microservices based on solution spaces, because this is going to help with the sharing and collaboration. And the understanding, if you're an application team, there is a great shipping service out there that you should use, and you should rely on that microservice developer to make sure it's going to perform in the way it should. And then new tooling. New tooling is required. We see tons of new tooling coming out around managing Kubernetes. We're going to start seeing more tooling about managing microservices, these service catalogs, and how to really start getting our arms around an SOA architecture where microservices can be leveraged. So think about building this as opposed to the previous picture. In this, we have one cluster and we can assume this is prod, test, or dev. And in that one cluster, we have the 3 stores. We have the candy, clothing, and toy store. And they're running in their own namespaces, and they have full control over what happens in those namespaces. They are communicating, however, outside of their namespace into the shared service namespace. And that is where they're picking up the shipping, the payment, and the cart service. Now, in this configuration, we have one cluster, 6 pods, and 4 namespaces, and we have no drift. That's the critical part, no drift. Microservice sprawl creates drift, and drift can be a dangerous situation. You know, I make it sound dramatic saying dangerous, but everybody has been there when you have a library that needs to be recompiled and relinked, and everybody has to move to that new version of that library because it is a critical update that we need, and everybody's consuming it. That is a monolithic approach. In a microservice SOA approach, all you're doing is updating it once, everybody gets it. So if we add dev, test, and prod to this, we have 3 clusters, 18 pods, and 12 namespaces. So I talked about tooling. I'm going to talk to you a little bit about Ortelius, which is an open source project that's incubating at the CD Foundation. I have the honor of being the community director for this project. We're super excited about its progress, and we have a ton of really, really motivated committers that understand this problem and are really working to solve microservice management and cataloging. So Ortelius tracks what I like to call a logical collection of services, creating a logical view of your application, and it adds versioning to that. So, you know, we talk about monolithic, and I like to talk about it as a massive puzzle piece that we laminate and we push through the life cycle. And microservices don't do that. Microservices take one puzzle piece and push it through the life cycle. So we have to start understanding how these pieces and parts work together. And that, in the essence, is the goal of Ortelius. And Ortelius can track the blast radius. It knows the impact. It knows if a microservice as update is coming across the pipeline and who it's going to impact. A critical part of an SOA architecture. So as soon as a container is registered, it's going to tell you who it's going to impact. You don't have to wait for it to be deployed. Now, Ortelius also uses this concept of domains. If you're working on a domain-driven design, it's going to allow you to build out a catalog where microservice developers can publish that microservice to a catalog, which means that there's some collaboration for application teams because they can look to see what's been published and consume it. It restores control by creating these logical application views. So think about when you, in a monolithic world, you take an application, you create a package. That package in a microservices world is going to include independently deployed components or microservices make up that application package. Okay, that's the base version. If one of those services are updated, you have a new version of your application. And if one of those services are consumed by 3 different applications, you have 3 new versions of your application. So we restore control. Ortelius really works on restoring control by tracking these logical application versions. It gives you a BOM report, and it gives you diff reports, and it gives you your blast radius report. So what we're doing is we're adding that visibility, not observability, into a microservice environment. So if you think about the difference, let's just talk about this for a minute. Ortelius does not run in your cluster. Ortelius sits on top of your cluster and integrates into the CD pipeline and does automated configuration management to grab this kind of information. In other words, it's reimagined CI. Observability runs in a cluster, and it's going to show you what your transactions look like. The goal of Ortelius is to provide you some high-level information so you can see who the usual suspect is. Usual suspect is usually the last thing updated, and you can see that through a difference report. So let's just think about how Ortelius works. Ortelius is called at the point in time that a container registry occurs. So once that registry occurs, it triggers Ortelius to version the microservice and track the application configuration management and build a relationship map. Now, the way it's primed is that an application team creates an application-based version and creates a package. And that package has all of the services that that application is going to use at its base version. Once a new container has been registered, we know that it's going to impact anybody who consumes the last version of that container. And we start building those maps. This is the essence of how it starts tracking and building this data or metadata of deployment information about how your microservices are being consumed and what your application looks like. Once that occurs, it can trigger the deployment, or it can be triggered to call your Helm chart, for example. And it does that so that we can get a return feedback. So we need to be able to see what occurred at the cluster level so we can report it back. So we're reporting the inventory of the microservice across all clusters that it's been deployed to. Now, why is that important? It's important because every cluster can look different, and every cluster can have a different collection of microservices. So every cluster has a different version of your application. This is not new. We've done this from dev, test, to prod for a long time. That's the whole point of having these different stages, because we have different versions of the application. And Ortelius tracks this information by creating that feedback loop that says we know that these are installed into this cluster, so we know what version of the application is running at any point in the life cycle. Tricky. It also has a full set of APIs so that you can call into it, and it does all of its magic, all of its versioning, and all of its relationship maps and its domain in a Postgres database. So just to kind of explore the kinds of maps that it does create, and we called it Ortelius after Abraham Ortelius. Abraham Ortelius created the first World Atlas, and he did so in a really cool way. He was sort of our first open source leader, because he understood that there were people all over Europe at the time who were sailing and building out maps of the world, and he pulled them together, and all these cartographers together, and created the first world atlas. He didn't take credit. If you look at some of his old maps, you can see where the different individuals who have created parts of the map or have kind of signed the maps. So he pulled together the knowledge of many people to build out our first world atlas. And in many ways, that's what Ortelius is doing, is pulling together information about these different microservices, where they're deployed, and it's creating maps. If you really want to think about it, we're taking a giant cluster and we're versioning every point in that cluster. And what we get are BOM reports at an application version. We can show the differences between those application versions. In this case down here, we're showing that the cart service was updated. And in this case, we're showing that the cart service was updated, and when it impacted 3 different applications. Now, this kind of data can easily be passed to the rest of the pipeline. So, for example, if this cart service has changed, we need to execute the test workflows for these 3 different applications. And in essence, what we're doing again is reimagining CI and understanding how the pieces fit together, so that we know that we have to notify these other application teams that something in their world is changing and they should know about it. So the results, feedback from our early adopters, they say they are seeing the reduction in sprawl of their microservice and redundant coding by about up to 50%. And they're saying that this automated configuration management saves 1 to 2 hours of manual work per deployment. Now, if you're doing 1 or 2 deployments a week, that may not be too much, but if you're doing them every day, or if you want to get to doing them every hour, that's a big number. SREs are now given the visibility to make some data-driven decisions before they do a deployment, like the blast radius. And we really are driving these high-frequency updates built into existing CD pipelines, so we can connect into the CD pipeline of your choice to evolve it to start managing the concept of microservices and doing that automated configuration management to get those reports. And that's the end. We are about out of time. Let's continue the conversation. You can reach me at Tracy at DeployHub. My Twitter account is at Tracy Reagan, and you can find me at Tracy-Reagan-OMS. Go to the Ortelius website, ortelius.io. You can check us out on GitHub. And if you're interested in contributing, we would love to have you. This is a big problem. We need as much input from SREs and developers and testers and operations folks as we can to really start pulling in the kind of data that we need to really create a solid hub of deployment metadata that keeps us all pointing toward the North Star. And that is Ortelius open source development in Google Groups. Thank you so much for listening. And hey, the JFrog folks, thank you for having me again. I love doing these. Love you all. Thanks.